Hello everyone, welcome to Calsoft podcast series. This is Adarsh Ranjan, your host for today's podcast. Topic for today's podcast is challenges of cloud application development. Allow me to introduce you to Rajesh Kaushal Upadhyay, our panelist for today. Rajesh is an AWS certified solution architect. He has 15 years of industry experience in developing enterprise applications. Currently, he is working as Senior Technical Lead at Calsoft and is contributing to cloud practices at Calsoft. Rajesh, I'm glad to have you here.
Thanks, others.
So without wasting any time, let's get the discussion rolling. So Rajesh, can you please briefly introduce today's topic?
Sure. Cloud has emerged as new application paradigm. It has changed the contours of IT infrastructure. It has opened new horizons, but at the same time, it has added new complexities. To leverage the benefits of cloud, we have to change the way we used to develop or design our applications. There are challenges in development of a cloud application, so we will discuss about those challenges today.
Okay. So what are cloud applications?
Before that, cloud are basically remote data center. Cloud applications are developed from scratch to run on cloud. It is also known as cloud native applications. It runs on remote IT infrastructure. Users use these applications over the network.
Okay. How they are different from traditional applications?
To understand cloud native applications, we have to first understand traditional applications running on either on your desktops or from on-prem data centers. You buy the license and run your copy of application on your desktop. This is called shrink and wrap product engineering. Cloud applications run on shared infrastructure. That infrastructure is managed by someone else. Users' data stored on cloud, it is being accessed over the network. Applications should be available whenever we need them. Hence, availability, scalability, security become very important factor for cloud applications. Also, licensing model of these applications are different than traditional shrink and wrap applications. You pay for what you actually use. Usage cost reduces drastically. We don't have to pay for hardware maintenance.
Okay. So you talk about some of the concerns such as availability, scalability, accessibility, and security. What are the other challenges of cloud applications?
Major challenge for cloud applications are availability, data management, messaging, performance monitoring, then security. Security includes data security, network security, identity management. Then our application should be resilient, multi-tenancy, use shared platform services, then scalability. So responsiveness of the system, ability of system to handle increase in load without impact on performance.
Oh, I understand. So how would you design and implement a cloud application?
Developers need to handle each and every term or challenge what we discussed just now in their application. They need to consider and incorporate right at the design stage itself. Each challenge is connected and dependent on other. So we cannot just pick few, solve it and leave others for future. We have to handle it all at the right from the beginning itself.
Okay. Can you explain this with some example just to elaborate more on this?
For example, we talked about resiliency. So resiliency is ability to gracefully handle and recover from failures. To increase availability of application, we have to make our application resilient. Efficient and secure data management is the key. We have to store our data on multiple nodes to make our data highly available. Then cloud instances where our applications runs may fail, and we have intermediate data stored on temporary storage will be lost forever. So to handle such cases, we have to store all our intermediate data on some persistent storage. In some cases, data is copied on multiple nodes. So the terms like eventual consistency or strong consistency comes into the picture. Another example could be application monitoring and analytics. Like when we have to constantly monitor performance of application, analyze the logs and usage data. Actually, in the beginning, analytics is not doesn't seem to be a very important factor, but when the usage increases, application analytics becomes one of the core function, detecting and understanding the usage pattern, providing recommendations which helps in taking decision. So analytics should be planned very early in the solution design cycle. Developer can use cloud design patterns to handle all these use cases in their application.
Okay. So looks like everybody needs cloud application now. Uh, so you talked about cloud design patterns. What are these cloud design patterns and how they are useful in resolving issues?
Um, Cloud design patterns are nothing but mixture of enterprise solution architecture, for example, pipeline, client server architecture, SOA, like service oriented architecture, then our object oriented design principles like abstraction, encapsulation, cohesion, coupling. Then we know design patterns by Gang of Four. Then we have construction patterns like component design, tier design, then delivery methodologies. So only difference is cloud design patterns refer to specific components or service provided by public cloud providers. Developers need not have to develop this component from scratch. They can directly use them whenever they need in their code. Developers can focus on their core business logic, not on the component design or development.
Wow. So how to select cloud infrastructure components of your application?
There are some core functional component of application of any application. Then there are additional supporting components that will help in managing the application in future. There are multiple cloud providers such as Google, then AWS, Microsoft Azure, then IBM Bluemix, and many other. At present, almost all provide complete suite of services to handle different needs of application. Selecting any specific cloud provider is more of a business decision. Developers can go through the service catalog of all cloud providers and take a wise decision. But going with one cloud vendor and building your solution around one cloud provider leads to vendor lock-in. Then solution providers want their application to be cloud agnostic. They don't want their application to be logged in with one specific vendor. So they want the application to work on multiple clouds. Applications can be designed to work with multiple cloud. Developers can use a multi-cloud approach to make their application cloud agnostic.
Okay. So you talked about multi-cloud. What is this multi-cloud approach?
Multi-cloud means you are using services of two or more public cloud providers in your application. You don't want to be vendor logged in. Due to market competitions, public cloud are not built to work together. But dealing with multiple cloud providers adds complexity to the code, because we have to deal with two or more public clouds. There are multiple technology stack, there are different security systems. So you have to come up with your own solution to integrate services from these multiple cloud providers. One of the solution could be using cloud management platforms. Again, there are many cloud management platforms available in the market. CMPs, these are called CMPs. CMPs provide a layer of abstraction between your application and the multiple clouds. So as a developer, I would suggest understand the business need of your application, invest your time in understanding the challenges involved, know what are the options available to you, and then design your cloud application which solves the problem of your target audience.
This was a great information for all of us. This brings to end of our podcast. Thank you, Rajesh, for an insightful podcast.
Thanks, Adarsh.
So guys, stay tuned to Calsoft YouTube and SoundCloud channels for more such insightful podcast. For any queries or feedback, do write to us at marketing@calsoftinc.com. We look forward to your valuable inputs. Thank you, Rajesh, once again, and have a nice day ahead. Thank you. Bye.